Okay, folks, Catherine during the break asked me, how does it keep turning back negative? And what I was saying is that this negative out front is going to keep turning them back negative. Every time I square a number, it's going to be positive. Because it's either a negative number times a negative number, which is positive, or it's a positive number times a positive number, which is positive. So anytime I square a number, it's positive, but this negative sign out here turns it back negative. Okay? So let's see what happens again now with y equals 2. So y is equal to the opposite of, or negative, 2 squared. Okay, well what is 2 squared? Well wait, let's do this. That's negative 2 times 2. Well, Catherine, what's 2 times 2? But then I've got a negative in front of it. So y is equal to negative 4. Okay, do you see the same thing's going to happen with the 3? Yeah. What am I going to get, Suzette, when I plug in 3? I'm going to get negative 9, exactly. Perfect. Now, let me get rid of this word. How many ordered pairs do I see up here? How many ordered pairs are up here? Jack? 7 ordered pairs. They want me to plot them in the coordinate plane and describe the pattern that I see. Okay, well let's do that. That's negative 3, 1, 2, 3, and then up, down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so there's my dot. That's the first one. Okay, and I've got 7 of them I have to do. The next one is go back 2, 1, 2, and down 4. All right, so that's right here. The next one is go back 1 and down 1, so that's right there. The third one, or the fourth one, is 0, 0. Okay. The fifth one is 1, negative 1. The sixth one is 2, negative 4. How would you guys describe this figure? Oh, how would you describe it, Ian? You know what? It's not. It's not. Let me show you what happens. I'm going to scoot this.
A tree?
I'm going to scoot this up a little bit. It has a name. It has a name. And that name is a parabola.
I was going to say that.
Now,
Yeah.
thank you. Do you see that it is symmetrical? If I cut it in half and fold it, it sits right on top of it, just like our projects that we did for the field trip that we took to the Crow Museum. It is symmetrical. Its name is a parabola. You see it often. For instance, you see parabolas on the Golden Gate Bridge. This shape right here is a parabola. It's turned up though. You see them also on the tops of houses. You may not know that you're seeing it. And this is mounted onto a roof. And this is a parabola right here. This is a dish for Dish TV or Direct TV. Because they have things, parabolas have something called focal points. Signals come down from a satellite, they hit the parabola and bounce back to the focal point. It always hits that. Okay? Now, stop, Harry, thank you. Now, this is a parabola. And every signal bounces back to this, which then takes it and runs it into your TV down the cable. Okay? All right? So this equation, the graph of it is a parabola. And this parabola has a certain equation that works for Dish TV, or Direct TV, stuff in our houses. All right, good job. Let's look at the next one.